Hello everyone, welcome to LeetCode Weekly, where every week we cover a few LeetCode problems. Here we have a harder version of the same problem from last week. Problem 3573, best time to buy and sell stock 5. We're given an array called prices, where prices of I is the price of a stock on day I. We're also given an integer k, which is the maximum number of transactions we're allowed to make. A transaction can be of one of two types. A normal transaction, or a long position, where you buy on day I, sell on a later day, and the profit is the price on the later day minus the buy on day. Then we have a short selling transaction, or a short position, where you sell on a day and buy it back on a later day. There are a few important rules. You must finish one transaction before starting another, you can't buy and sell on the same day, and each transaction counts as one, no matter whether it's normal or short. Your goal is to compute the maximum total profit you can make at most using k transactions. So a straightforward idea would be to try every single possible pair of buy and sell or sell by days, and we'll try every possible combination up to k transactions, and we pick the combination that gives the most profit. Or in other words, we enumerate through all possible transactions, and then try all the ways to choose up to k non-overlapping ones. Well, this approach completely fails with complexity. There's O of n squared possible transactions, which means choosing combinations of them leads to exponential time. And with the length of the prices being up to 1000, this is completely impractical. Even with pruning or memoization, the state space is far too large, so we need something smarter. And this is where dynamic programming steps in. On any day, you can be in exactly one of three states. You can either not be holding anything, so the transaction is complete, you can be holding a long position, where you've bought but not sold yet, and you can be holding a short position, you've sold but not bought back yet. And a transaction is only counted when it's completed. Opening a position does not consume a transaction, but closing a position does. This makes the problem great for dynamic programming. So for our DP state definition, we're going to let t be the number of completed transactions between 0 and k, and we'll track three values for each t. Flat of t, which will be the max profit holding nothing, long of t, max profit holding a bought stock, and short of t, max profit holding a sold stock. So for day by day transitions, for each price, we'll be opening a long position and a short position from flat. From long, we'll close it because the transaction is completed, and from short, we'll close it because the transaction is completed. Each transaction updates profit accordingly. This is efficient because we have less than or equal to 1000 days, less than or equal to 500 possible transactions, and a constant 3 states per transaction. This leads to a time complexity of O of n times k, and a space complexity of only O of k. This is fast enough and clean. So to start with our solution, we're going to create a variable called infinity. This will be 10 to the power of 30, or any large value. This is to represent impossible states. Now I'll create a new variable flat, which will be 0 multiplied by k minus 1. So this will be an array of zeros with a length of k plus 1. Now create a variable called long, and this will be an array of minus infinities times k plus 1, and then an array called short, which again is an array of negative infinities multiplied by k plus 1. Now for price in prices, I'm going to create a new loop for t in range k minus 1 minus 1. This is going to loop backwards to avoid overwriting needed states. If t is less than k, so we can only close a transaction if we still have room, we're going to update our flat array. So flat at t plus 1 equals the maximum of flat at t plus 1. So this will be keeping our previous best flat state. Long at index t plus the price, so we're going to close our long position, and then short at t minus price. This will be closing our short position. Now outside of this if condition, we're going to create a new line, long at index t equals max of long at index t, so we're going to keep holding our long position, and we're going to open a new long position, so this will be flat at t minus price. And we'll do pretty much the same thing for our short. So short at index t equals max of short at index t, and flat at index t plus price. So we're going to keep holding our short position or open a new short position. And at the end, we can return the maximum of our flat. This is because the best profit must end with no open position. So if we run this, it's been accepted, and if we submit, there we go. Thanks for tuning into LeetCode Weekly. If you enjoyed this video, then be sure to like and drop a comment down below. Thanks for watching.